Okay with it. We can start today's lesson in heat. Now we are in the later part of heat means calorimetry lesson. As we discussed earlier in our previous lessons, it is very clear how to exchange heat. How to exchange heat. Then the hot material means the material with high temperature gives heat, and the material with low temperature absorb that heat. So if there is no heat loss to the surrounding, we can equate the removed heat from the hot material and the received heat by the cold material. Okay, so we have done some several applications, several calculations. Okay, so that is based on Q equal MC theta equation, and Q equal MC theta equation shows the heat energy absorbed or released without any phase change. But sometimes when heat is absorbed by a material, there may be phase change. Therefore, now we are going to discuss such a cases. That means if there is a phase change, how to calculate that heat absorption or heat loss. How to calculate that thing. Okay. Okay. So, you know, if we consider about a material, any lattice, there are intermolecular bonds. In between those atoms, in between those molecules. So, if you want to break those intermolecular bonds, we have to give a energy. We have to give an energy. That energy is a heat energy, definitely. But if you want to break this bond, definitely you have to increase the energy. You have to increase the kinetic energy of this particle. You have to increase the kinetic energy of that particle. By increasing the kinetic energy of particle, you can break those bonds. And then you can release this material. You can release this atom. Therefore, if you want to break bonds, that means when breaking bonds, definitely there's a heat absorption. There's a heat absorption when breaking intermolecular bonds. Otherwise, we cannot break intermolecular bonds for it. Then, what will happen when it comes to the reverse process? Reverse process එකට આવොත් දැන් මොකද වෙන්නේ කියලා බලමු. That means, suppose now there is a air, so gas state. Suppose now there's a gas state. So as this is a gas state, you know, those materials or those particles have very high kinetic energy. And now, by decreasing the temperature, I can freeze this gas. And as an example, suppose water vapor put it. So at Celsius, 100 Celsius, the water will be converted into a vapor. Vapor means it is a gas state. Okay. So if I decrease the temperature, what will happen? If I decrease the temperature, what will happen? Hmm? The energy inside that material, the energy inside that material decreases. Decreases. Okay. Therefore, when they are forming bonds, when they are forming bonds, they will come to stable position. That means their kinetic energy will be decreased with it. And when there's a bond formation, when there's a formation of bonds, definitely those materials or those particles come to a stable position. That means their kinetic energy decreases. As a result of that, the energy of that material should be released. Should be released. Um, uh, That means that means when there's a bond breaking, definitely the heat energy is absorbed by the material. On the other hand, when there's a bond formation, heat energy will be released by that material. Is that clear? If it is clear, please raise the hand. තේරෙනවද උස්සන්නේ? ඒ දෙකේ වෙනස තේරෙනවද උස්සන්නේ? I need responses from everyone. Yeah. They write that thing. Heat exchange. This is topic, Pute. This is topic. Final topic. Heat exchange during a phase change. Heat exchange during a phase change. Heat exchange during a phase change. During a phase change, during a phase change, during a phase change, the intermolecular bonds, the intermolecular bonds, the intermolecular bonds can either be, can either be, can either be break or reform. Reform. When there's a bond breaking, when there is a bond breaking, when there's a bond breaking, inner particles, inner particles absorb heat energy, absorb heat energy. Yeah. Number one, this one only. Are they right under that? Yeah. When there's a bond formation, when there's a bond formation, when there's a bond formation, come on. When there's a bond formation, the particles will come to a stable position. When there's a bond formation, the particles come to a stable position. As a result of that, their kinetic energies decreases. Their kinetic energies decrease. As a result of that, their kinetic energies decrease. So when there's a bond formation, when there's a bond formation, when there's a bond formation, heat energy will be removed from the material. Heat energy will be removed from the material. You can know this one. මේක අදගන්න. Draw this. හරි. There are topic. The factors, the factors, the factors affecting, the factors affecting the factors affecting to the heat absorption or removing the factors affecting to the heat absorption or removing during a phase change. During phase change. Then බලමු පුතේ අපේ මෙතන තියෙන factors එක. This is very interesting part. This is very interesting part. Please listen to me very careful. So during the first change, during phase change පුතේ what happens? මොකක්ද වෙන්නේ? Phase change එකක් ඇතුළේ මොකක්ද වෙන්නේ? Definitely during a phase change bonds can be break or reform. No, Bhuti. That means they are actually during a phase change. During a phase change, Bhuti, actually there can be two things. Actually, two things can be happen. Okay, one is bond breaking. Bonds break can come. Or bond formation. Bond formation. Right? Those are the things that can be happen during a phase change. Therefore, no matter whether it is bond formation or bond break input here, during a phase change, there's only one thing happen. What is that thing? What is the thing? The number of bonds change, Puti. The number of bonds change. Yeah. So when there's a bond break-in, the number of bonds decreases. When there's a bond formation, the number of bonds increases. Therefore, during a phase change, so what is the common feature? What is the common feature? No matter whether it is a bond formation or bond break-in. So what is the common factor? The common feature. The number of bonds change. The number of bonds change. Therefore, that means number of intermolecular bonds change. Is that clear? If it is clear, please raise the hand. Hey, one person. Hey, one person. If you got that thing, please raise the hand. Hey, one person. Kute mata atishay adara ogala respond ekla. I need responses from everyone. Go. No. Thank you. Thank you. Thank you. Thank you. දැන් බලන්න පුතේ එහෙනම් බලන්න ඕනි මේ number of intermolecular bonds වල බලපාන fact එක තමයි දැන් බලන්න. නේද? දැන් බලන්න පුතේ. දැන් බලන්න. Suppose now have we got failure. Okay. There are no mistake. Therefore, during a phase change, the number of intermolecular bonds changes. The number of intermolecular bonds changes. The heat absorption or releasing. Heat absorption or releasing. Depends on depends on two factors. Two factors. The heat absorption or releasing depends on two factors. Main factors first one is number of intermolecular bonds break or generated. Break or generated. That means if you want to break 5 bonds, we need a certain energy. But if you want to break more than 5 bonds, that energy might not be sufficient to take. We have to supply more energy. Therefore, the heat absorption or releasing depends on number of intermolecular bonds break or generated. Okay. Is that clear? If it is clear, please say there. Clear to somebody? ඒ කියන්නේ පුතේ bonds 10ක් හැදෙන්න ඕන නම් එතන තියෙන එනර්ජි එක නෙමෙයි bonds 20ක් හදනකොට. හරි. bonds 20ක් break කරන්න ඕන නම් එතනට අවශ්‍ය එනර්ජි එක නෙමෙයි bonds 100ක් break කරන්න ඕන. දෙන්න ඕන එනර්ජි. Definitely bonds ගන්න වෙනස් වෙනවා. When the number of bonds varies, the heat associated with those bonds definitely varies. Is that clear? If it is clear, please raise the hand. The number of bonds, Pute. Number of bonds means we cannot count down that thing. We cannot count, no? How to count number of bonds? By looking at the material? No, we cannot. But we know another physical quantity that influence to the number of intermolecular bonds. That is mass. That is mass, Pute. So when mass increases, when mass of the object increases, you know the number of particles increases, Pute. That means number of intermolecular bonds increases. When the mass decreases, the number of particles decreases. That means number of intermolecular bonds decreases. Therefore, if you want to melt 5 kg mass of metal ball and 10 kg mass of metal ball. Suppose we want to melt 5 kg mass of metal ball and 10 kg mass of metal ball. It is very clear in 10 kg mass of metal ball there are a lot of bonds. There are a lot of bonds because its mass is higher. As its mass is higher, the number of particles increases. That means number of intermolecular bonds increases. Therefore, if you want to melt, definitely you have to break all of those bonds. And that means the energy associated with those bonds definitely high. Therefore, number of intermolecular bonds, we cannot measure that thing, but we know how to measure it. Because that is actually that depends on mass. That depends on mass. And that means the heat absorption or releasing during a phase change depends on mass. Depends on mass. That depends on mass. When mass increases, the heat associated with the phase change definitely increases. If you got my explanation, please raise the hand. Devna Nathusan, I need responses from everyone. Have a good. Perfect. They write the first one. Number of intermolecular bonds break or generated. Write on that. Write on that. Suppose we need to melt 5 kg metal ball and 10 kg metal ball. Number of intermolecular bonds in 10 kg ball. Number of intermolecular bonds in 10 kg metal ball. Is higher than 5 kg metal ball. Therefore, during melting, 10 kg metal ball should absorb more heat energy. 10 kg metal ball should absorb more heat energy. Or number of intermolecular bonds break or form depends on mass. Depends on mass. Therefore, heat exchange during a phase change depends on mass. Therefore, heat exchange during a phase change depends on mass. That means Q depends on mass. Q depends on mass. That. Then the second factor, which is the strength of intermolecular bond. The strength of intermolecular bond. Healthy. Yeah. Then the next factor is the strength of intermolecular bond. Now it is very clear, if the strength of intermolecular bonds is very strong, it is very hard to break. It is very hard to break. That means it requires more heat energy. We have to give more heat energy to break such a bond. And on the other hand, if there's a bond formation, that formation is very, very stable formation. That means the kinetic energy of those more particles definitely decreases in a high range Putin. Therefore, when the bond is very strong, definitely the heat associated with that bond increases. If the bond is very easy, very weak, Pute, it is very easy to break. So in such cases, the energy requirement is very low. And therefore, definitely, the absorption or releasing of heat energy depends on the strength of bond. The strength of bond. And Pute, the strength of bonds means that is a material property. That is a property of that material. Material to material, the strength of bond varies. No, if we consider about ferrous means iron ball, and if you consider about a plastic ball, definitely those are two range of intermolecular bonds. If you consider about again iron ball, and if you consider about water, definitely there are two types of material intermolecular bonds, and the strength also varies. Therefore, material to material, the strength of intermolecular bond varies. As a result of that, the absorption or releasing of heat depends on material. It depends on material. Therefore, when the strength of intermolecular bond increases, Q increases putih. Therefore, the strength, sorry, repeat. Heat exchange during the phase change depends on the strength of intermolecular bond. Therefore, this is Q putih. Therefore, Q depends on the strength of intermolecular bonds. The strength of intermolecular bonds. The strength of intermolecular bonds. Putih, the strength of intermolecular bonds is a material property. This is a material property. This is a material property. Material property. Therefore, Q depends on material type. Material type. Therefore, there are two factors. So, if there are two factors that can affect to the exchange of heat during the phase change, those are mass and type of material. Type of material. Actually, this is very much similar as Q equal MC theta. Q equal MC theta. The only difference is there is no temperature difference with it. There is no temperature difference during the phase change. Therefore, temperature is not a factor here. That is the only difference. The other two factors are in this equation too. The other two factors are in this relationship too. The only difference is there is no temperature factor because during the phase change, temperature is a constant. Therefore, we don't actually, it won't be affected to the phenomena. And that is the only reason, only difference. Is that clear? If you got my explanation, please raise your hand. Okay, Donatus. Thank you. එහෙනම් පුතේ අපිට මේකේ equation එක build කරන්න පුළුවන්. Therefore Q depends on mass. Q depends on mass පුතේ. Material type we cannot take a we cannot measure that thing පුතේ. That means Q depends on mass. So this relationship, if I convert this relationship into an equation, there will be a constant. There will be a constant. Now, if I convert this into a relationship equation, there's a constant. Definitely, this constant should represent the other factor. This constant is called the latent heat. The latent heat. The latent heat. Therefore, this is a constant. And it represents material type. It represents material type. And it is called the latent heat. It is called the latent heat. It is called the latent heat. Then I can write some Q. Then I can write the equation Q equal ml. So this is the heat exchange. This is the heat exchange during a phase change. Q equal ml. Q equal ml. Is that clear? If it is clear, please raise the hand. Tape not son. I need responses from everyone. Very good. Tak kalian. Hello. I finished writing. Eu estou sabendo que a vida ඇතර මේ අපි සාමාන්‍යයෙන් ගත්තොත් එහෙම මේ ෆිසික්ස් වල පුතේ මෙතන තමයි ගොඩක් වෙලාවේ දුකින් තමයි ෆිසික්ස් වල කියන්නේ. තියරිටිකල් පැත්ත හැදලා තියෙන ගොඩක් වෙලාවට හීට් ලෙසන් එකත් එක්ක. මේකෙන් එහාට ඉස්සරහට හරි ගිහලා තමයි ගොඩක් දේවල්. ඒ කියන්නේ ඔය මේ මොඩර්න් ෆිසික්ස් කියන දේවල් ඇති වෙලා තියෙනවා. මොඩර්න් ෆිසික්ස් වලට ආවේ මට රේඩියේෂන් එකත් එක්කනේ මට රේඩියේෂන් කියලා කියන්නේ
ඉනිෂල් පාර්ට් එකෙන් ඔය ඇතුලේ තියෙන ඔය මොලිකියුලර් ස්ට්‍රක්චර් එකේ ෆිසිකල් බිහෙවියර් එක නැත්නම් අපි ෆිසික්ස් වලට දාලා ඉංජිනේරින් එක හොයාගන්න ඒ කරපු try එකේ ප්‍රතිඵලයක් විදිහට තමයි මොඩර්න් ෆිසික්ස් සහ කොහොමද ඒක එක පැත්තක් තමයි කෙමිස්ට්‍රි කියන්නේ. ඒක එක පැත්තක් කෙමිස්ට්‍රි කියලා කියන්නේ. අතරම මේ මොකක්ද ඔය කොහොමද ඒක සම්බන්ධද මොකද ඉස්සලා වෙනවා අපි ලෙසන් එක ඔයගොල්ලෝ ඉංග්‍රීසි වල තියෙනවා මම හිතන්නේ කෙමිස්ට්‍රි වලට තියෙනවා ඔය මේ මොකක්ද මේ gas laws ඊට පස්සේ මොනවද මේ chemical structure molecular structures ගැන කතා කරන්න තියෙනවා ඒක දෙකම තියෙනවා ෆිසික්ස් වල එහෙමම තියෙනවා ඊට වඩා ඒ තරම් ලොකු දෙයක් නෑ අඩුයි තියෙන්නේ හවුද ඒකට ගැන ක්වෙස්චන්ස් එකකට එහෙම අනිවාර්යෙන් හිතන්න ඕනි පැති ගොඩක් තියෙනවා. කියන්නේ හරියටම තේරුම් ගන්න යන ඕනි පැති ගොඩක් තියෙනවා. ඒ නිසා මේ අනිත් ක්වෙස්චන්ස් වගේ ලේසි නැහැ ක්වෙස්චන් එක. ලේසි නැහැ. ඒකේ තියෙන වැල්වටාරන් දාන සහ ඒ තේරුම් ගන්න ඕනේ ගොඩාක් වෙයි. ඒ පැටිකල් එකක් ගත්තත් ඒ වගේ පැටිකල් එකේ කතා කරන්න ඉවර තියෙන කප්පොරක් විතර. සාමාන්‍ය ප්‍රැක්ටිකල් එක ලේසි නෑ ඉවර කරන්නත් හරි. ඒ කියන්නේ කතා කරන්න ගත්තා ඒක ඇතුලේ කතා කරන පුංචි තැන් තියෙනවා. ඒ කියන්නේ හේතුත් එක්ක ගොඩක් දේවල් තියෙනවා. මේ ඒ නිසා මේ පොඩ්ඩක් දිගයි. දිගයි කියලා කියන්නේ අතරම කතා කරන දේවල් ගොඩක් තියෙනවා. බලන්න. Have we know this thing now? U equal ml equation. But in this equation, this term is called specific latent heat. The specific latent heat. विशिष्ट गुप्तता का क्या कहते specific latent heat. Have. So depending on the phenomena, depending phenomena means actually there are two phase changes. There are two phase changes. One is liquid to gas. Other one is solid to liquid to solid. There are two phase changes. Therefore, depending on those two phase changes, we can name those L factor. Suppose now there is a solid formation. At a certain temperature, then we bring the solid formation into its melting point. So during the melting point, actually now solid plus liquid formation करती है. Solid plus liquid formation. This is the melting point. This is the melting point. Then during the melting point, then what will happen? Then this one will be fully converted into a liquid. Now this is liquid at melting point. Temperature වෙනස් වෙනා නැහැ. හරිද? Make a solid at melting point. මම මේක solid කියලා දාන්නම්කෝ. Solid at melting point. The liquid at melting point. Then, initial solid, suppose this is ice put it. Now ice brings to 0 Celsius. 0 Celsius means now this is 0 Celsius ice. That means solid at melting point. Now it converts into a water, that means liquid at Celsius 0. Liquid at melting point. Then we can further increase the temperature. We can further increase the temperature. Then what will happen? This material comes to the boiling state. Now there's a liquid at boiling point. So at the boiling point, what will happen? The entire liquid will be converted into a gas. Therefore, this one will be converted into a gas. Yes. Now this is a gas at boiling point. Okay. So during this phase change, during this conversion, solid at melting point. Solid at melting point means there's no phase change. Still there's no phase change. Therefore, heat associated with this transformation. Heat associated with this transformation can be determined using Q equal MC theta equation. Because temperature change. This is the initial temperature. Now this is the second temperature it varies. But during this phase change, make a transformation. The solid state at a certain temperature is converted to same solid state but at melting point. Now it converts into liquid at melting point. Therefore, temperature is equal. So the heat energy associated with this conversion can be measured using Q equal ML equation. When it comes to solid liquid transformation, we call it as fusion. Fusion. And a solid liquid transformation means it is a fusion. Therefore, the specific latent heat associated with that transformation or that phase change is called the specific latent heat of fusion. We can represent it as a simple L. Capital L and vaporization. So this is called the specific latent heat of fusion. Specific latent heat of fusion. Then now it's again put it is converted into liquid form. But now that liquid form is brought into the boiling point, but is still the phase is same. Still the phase is same. There's only temperature difference. There's only temperature difference to be done. Therefore, heat associated with this transformation can be measured using MC theta equation. Now, at the boiling point, now there's a phase change. Liquid form is converted into a gas form. So heat associated with this formation can be measured as Q equivalent. Okay. So this latent heat is called as the specific latent heat vaporization. That's a capital L. And whether with a specific latent heat of fusion, method a specific latent heat of vaporization. Therefore, this process is called fusion. This process is called vaporization. Is that clear? If it is clear, please raise the hand. Right. Okay. Have finished? Have finished? Right. Then another topic is specific latent heat of fusion. Specific latent heat of fusion. Specific latent heat of fusion. That is topic. Now we can define that thing with it. The specific latent heat of fusion. Q equal M simple L, therefore simple L is equal Q over M. Q over M. Yeah. Therefore, unit, you know this one is measured by joule, this one is measured by kilogram. Therefore, unit should be joule per kilogram. Joule per kilogram. Then the definition. How to make a definition? As I told you earlier, if there is a fraction, equate the denominator to 1. Equate the denominator to 1. If denominator is 1, the numerator should be equal the left-hand side. Numerator should be equal to the left-hand side. That means when M is equal 1, Q is equal simple L. Very clear definition then. Kailangan, mukha ko tayo definition එක. This is the heat නේ Therefore, heat required to convert unit mass of a solid. Unit mass of a solid to liquid. Without changing temperature. Is called specific heat. So specific latent heat of fusion. Is specific latent heat of fusion. So if you consider about water, the specific latent heat of fusion of water. That is 3.36 into 10 to the power 5 joule per kilogram. Kailangan. Hello. So now this is specific latent heat of fusion. Then right, the other topic is the specific latent heat of vaporization. Vaporization. The specific latent heat of vaporization. The unit is same. This one also same if we convert unit mass of liquid. That should be liquid to vapor. It is the heat required to convert a unit mass of liquid into a vapor without changing the temperature is called the specific heat of vaporization. Vaporization. So during the vaporization, Bhute, you have to break all the bonds. But during fusion, you don't want to break all the bonds. Right? In a liquid, there are bond clusters. Therefore, you don't want to break all the bonds. You have to break some certain amount of bonds only. But during vaporization process, you have to break all the bonds. Therefore, it requires more energy. More energy. I think we have written the thing. Therefore, no need to write that thing. But it is very clear the specific latent heat of vaporization. Normally, we call it as capital L of water. That is equal to 2.24 into 10 to the power 6. 10 to the power 6 joule per kilogram. අරවගේ කියද අරවගේ නිකන් 7 times වගේ වෙලා තියෙනවා නේ. මේ 10 to the power 5 එකත් 22.4 නේ පුතේ. 22.4 අරක 3.36. It is something 7 times higher than the previous one. Line. Hello, Uday. Okay, then write this question. Write this question. Find the final temperature of the system. Find the final temperature of the system Find the final temperature of the system if 40 grams of ice 40 grams of ice at 0 Celsius 40 grams of ice at 0 Celsius is added to a calorimeter is added to a calorimeter 100 grams of water is added to a calorimeter with 100 grams of water 100 grams of water at 20 Celsius at 20 Celsius at 20 Celsius. Neglect the heat exchange with the surrounding. Neglect the heat exchange with the surrounding. Those are the given data to take heat capacity of calorimeter. Heat capacity of calorimeter is equal 320 joule per Kelvin. 320 joule per Kelvin. Second data, the specific latent heat of ice. The specific latent heat of ice is equal 3.36 into 10 to the power 5 joule per kilogram. The specific latent heat of fusion. The specific heat capacity of water. The specific heat capacity of water is 4,200 joule per kilogram per Kelvin or Celsius. Those are given data. You need to calculate the final temperature of the system. Final temperature of the system. Okay, Putri. Shall we look into the question? Tagawan ham question area. Everyone, please look at the board. Now this is a heat exchange question, Putri. Exchange of heat question. Definitely there should be a material. There should be a material who gives heat. And there should be a material who receives heat. Now tell me who gives heat. How the heat how the heat who gives heat and who receives heat. ඒක තමයි ලෙහා ගන්න තියෙන ඉච්චරම තමයි කරන්න තියෙන්නේ. කවුද දුන්නේ කවුද ගත්තේ? භාගයට කියන්න එපා භාගයට කියන්න එපා. Who gives heat? Very good. No, භාගයට කියන්න එපා. පුතේ බලන්න මෙතන තියෙන material ඔක්කොම හිතන්න. You have to consider all the materials. You have to consider all the materials. There are 3 materials, not only 2. කවුද heat එක දුන්නේ? Yes, listen, correct. Yes, water, calorimeter, yes. Calorimeter and water gives heat. Twice, yes, very good. Now then, definitely if there's no heat loss, there's no heat loss. If no heat loss. Definitely the heat given by calorimeter plus water. The heat given by calorimeter plus water should be equal. May equation එක අනිවාර්යෙන් ලියන්න. නැත්නම් වරදින්නේ නැහැ. Heat absorbed by heat absorbed by ice. But now there's a problem here. So we can equate this thing. If there's no any phase change. But now there's a phase change. So if there's a phase change, definitely you have to more careful. You have to careful. Suppose if this ice cube is enough to freeze this water, then what will happen? This ice cube will not be melted. Instead of that thing, this water will be freeze. Is that clear? If this ice cube has enough energy to freeze this one, the water will be freeze rather than melting of ice cube. And therefore, first you have to distinguish whether there is a melting of ice cube or freezing of water. Because definitely there is a phase change. But I don't know that phase change is melting of this ice cube or freezing of this water. How to determine that? How to distinguish the thing? Did you get my point? පැහැදිලිද? Is that clear? Therefore, when you are doing this kind of question, you have to determine what is the material that are going to subject for a phase change. Okay. The first thing you have to determine what is the material that will be subject to phase change. Is that clear? මං කියන දේ තේරුණා නම් තුස්සන් පැහැදිලි නම් තුස්සන් I need responses from very man. දැන් පුතේ පැහැදිලිනේ. ඒ කියන්නේ මම දන්නේ නැහැ පුතේ මේ ice cube එක තියෙමේද ice cube එකේ තියෙන අර heat එක නිසා එතන තියෙන මේ temperature නිසා water freeze වෙයිද කියලා මම දන්නේ නැහැ. water freeze වෙන්න පුළුවන් දෙක freeze වෙන්න පුළුවන්. දැන් අපි ලොකු ice cube එකක් දැම්මොත් එහෙම water වලට සාපේක්ෂව water එක freeze වෙනවා. හරිද? ඒ නිසා ඒක මම දන්නේ මොකක්ද කියලා. හරි. ඒ නිසා first you have to determine that thing. අන්න බලමු මේකේ ලියා ගන්න පුළුවන්. Write down that thing. There are two possibilities. There are two possibilities in this question. There are two possibilities in this question. First one. First one. The water inside the calorimeter, can be freeze. Ice cube. The water inside the calorimeter can be freeze without melting the ice cube. Second thing. The ice cube can be melted. The ice cube can be melted. And the temperature of the system will be decreased. The ice cube can be melted and the temperature of the system will be decreased. Without changing the phase of water. Without changing the phase of water inside the calorimeter. Without changing the phase of water inside the calorimeter. බලපොතේ එහෙනම් මට දැක්කම පුළුවන් heat release උදේ මෙයා freeze වෙනවා if if water is going to be freeze, that means the 20 Celsius water will be converted into 0 Celsius water. 0 Celsius water first. 20 Celsius water will be converted into 0 Celsius water first. Therefore, I can calculate that heat amount. Heat released by water plus calorimeter when converting 20 Celsius to 0 Celsius. බලන්න Q1 කියලා. So that is equal heat capacity පුතේ මෙතන තියෙනවා C ඇවිල්ලා T20, that is C's capacity. Then this one MC delta theta, or delta theta then delta the poly. This is calorimeter. This is calorimeter. Calorimeter into temperature change. Temperature change means 20 plus the heat released by ice cube. The heat released by ice cube. So that's good, right? This is the heat released by calorimeter. Now heat released by water. Again here. Then grab C again. That means 0.1 kg into 4,200 into 20 Celsius. මේ calorimeter පුතේ 20 Celsius වලින් අඩු කරනකොට අවශ්‍ය release heat එක මේ තමයි water 20 Celsius වලින් අඩු කරනකොට heat release වෙන heat එක. බලමු කීයද? Então, peraí, vamos ver aí. Pega uma. Aquela só isso. Aquela só eu quero me ver aí, por aí. Vai. Vamos ver tempo. Oh, sorry. එතකන්න වෙලුසි. එතකන්න මම තේරෙන්නේ මොකක් හරි පොස්ට් එකක් උනාදෝ කියලා හිතුවා. එන්න මේක තමයි පුතේ heat released by water plus thermometer again converting 0 Celsius 20 to Celsius 0. මේක මෙන්න මෙතන කරා. දැන් එනම් බලමු මෙයා මෙල්ට් කරන්න ඕනේ heat එක. මෙයා මෙල්ට් කරන්න ඕනේ heat එක. Heat required to melt the ice cube. But Q2 can take ml. ml, M means 40 grams. 40 grams into L means this one. 3.36 into 10 to the power 5. මේක යනවා 3.5 delta. උතන එන්නේ කීයද? මේ දෙකට එක විදිහට ඕෂේ තියනවා. දැන් බිඳුවයි ධාතුන්ගේ සාරසිය තමයි. බලන්න පුතේ. Now, now it is very clear. It is very clear. This ice cube requires 13,440 joule to fully melt. And so, when this object, when water plus calorimeter, the water plus calorimeter, when they're going to freeze, actually they will release this much of heat. They will release 14,800 joule. They will release that much of energy. And ice requires only 13,000 or something. That means what will happen? Ice can get fully energy. Fully energy means ice can get energy from this and it can be melted. And how the melting? Ice පුතේ. Ice melt කරනවා. මොකද ice melt කරන්න අවශ්‍ය 13,440. මේ ආකාර ගාව තියෙනවා 14,000 ගාන. 14,000 ගානක එනර්ජි එකක් මොකව තියෙනවා. එහෙනම් මුට පුළුවන් melt කරන්න. එහෙනම් මේක freeze වෙන්නේ නැහැ. freeze වෙන්නේ නැහැ. වෙන්නේ අක melt කරනවා. Is that clear? Because water plus calorimeter has very high energy, but ice requires somewhat lower energy to melt. Therefore, definitely ice will be melted. Is that clear? I need responses from everyone. Right. Therefore, I can write today, therefore Q1 is higher than Q2, therefore ice will be melted. Ice will be melted and convert into water. මේක දාගන්න පුතේ මට පොඩ I want to open it. they may make it. Heat capacity. Heat capacity of calorimeter. 320. Heat capacity. Heat capacity. Heat capacity means in MC product. Exit theta and heat capacity. Heat capacity කියන්නේ මොකක්ද? Heat capacity කියන්නේ capital C. This capital C. Capital C is equal MC. MC product. මතකද? What is heat capacity equation? Heat capacity is equal MC. Therefore, Q equal MC theta O. Without writing MC, I can write C theta. Compute heat capacity into theta. පැහැදිලිද? ඒක ඕන දාගන්න මම උතරේ. මම කිව්වේ නෑ කියන්නේ මතකයි කියලා. හිතලා මම කිව්වේ නැත්තේ. අමතක කරලා මෙතන දාගන්න හිතේ. අමතක කරලා මෙහා කොහොමද දාගන්නේ? ඔය පටලවා ගන්න එපා. ගොඩාක් වෙලාවට පටලවා ගන්න heat capacity එක දීපුවාට පස්සේ heat capacity එකත් එක්ක ළමයි පොඩක් පටලවා ගන්න අවස්ථා තියෙනවා. යුනිට් එක අනිවාර්යෙන් බලන්න. සමහර වෙලාවට simple capital මාරු වෙන්න පුළුවන්. simple capital එකපාරට ඔලුවට යන්නේ නැහැ. හරිද? දැන් අපිට simple C capital C එකපාරට අඳුර ගන්න බැහැනේ පුතේ. ලොකු පොඩි වෙනස විතරනේ තියෙන්නේ. ඒ වගේ වෙලාවක සමහර වෙලාවට ඕගොල්ලෝ mistakenly ගන්න පුළුවන් මේකේ specific heat capacity. හැම වෙලේම මේකත් එක්ක ඩීල් කරද්දී යුනිට් එක බලන්න. යුනිට් එක බලන්න මෙතන තියෙන මේ කෙල්වින් per joule විතරයි. ඒ කියන්නේ ආ මේක ටෙම්පරේචර් එක වැඩි කරගම ජූල් වෙනවා. දැන් බලමු පුතේ මොකද වෙන්නේ. Now it is very clear. Now it is very clear. This water bus calorimeter, the temperature of water bus calorimeter decreases up to a certain temperature. Then this ice cube will be melted and converted into water. Converted into water at Celsius 0. And after that, that Celsius 0 water will be converted into final temperature. Final temperature. Therefore, the left hand side is put in a heat given side, right hand side is his absorption side. Put a mama given side technically now given. Therefore, if the final temperature is theta, heat given by calorimeter plus water to convert the from Celsius 20 to theta. I don't know theta. 20 then theta and what is heat loss. That should be equal. Now this heat is absorbed by ice cube. This heat is absorbed by ice cube. Absorbing that heat, what will happen to the ice cube? It will be converted into 0 Celsius water. First, මුලින්ම වෙන්නේ එක. මොකක්ද? Ice cube converting ice cube into 0 Celsius water. Water. That involves ml heat. Then, now this water is at Celsius 0. Now this water is at Celsius 0. That water should be actually the temperature of that water should be increased up to the final temperature. The final temperature. And, that means Celsius 0 Celsius water is converted into theta Celsius water. MC theta. And then 0 Celsius water will be converted into theta Celsius water. Theta Celsius water. Therefore, using this heat, there are two processes to be done. One is converting 0 Celsius ice cube to 0 Celsius water. That involves, we can determine that by ml equation. Then 0 Celsius water into theta Celsius water. As it is the same phase, we can use MC theta. Therefore, this energy is 40,800. මේකම ගත්තේ නෑ නේද? ඒකම ගත්තේ නෑ දන්නේ නැහැ නේද? මොකද කියන්නේ? දැන් ලියන්න පුළුවන් temperature difference එක 320 plus මේ දෙන්න ප්‍රොඩක්ට් කරොත් එහෙනම් පුතේ 420 0.1 into 20 minus theta. 20 minus theta කියලා දැම්මේ මේ දෙන්නටම ඒ කියන්නේ මොකද්ද? කැලෝරීමීටරයටයි water වලටයි දෙන්නටම temperature difference එක common. ඒකම දෙන්නටම common එකක් දැම්මේ. This is equal to this one. Therefore, if I simplify this one, this will be cancelled now. 420 plus 320 means 740. 20 minus theta is equal ml. ml के दान में पे आगे वो है ml 13,440 plus this one. C के दे C water ले बोले m minus n ने बोले m के ने 40 में करवाई I think neutral पास I think एक वाली एक है ice ටික දිය වුණාට පස්සේ ice වල mass එක වෙනස් වෙන්නේ නැහැ. ඒ ice වල mass එක වෙනස් වෙන්නේ නැහැ. ඉතින් ඒ ටික එහෙම තියෙනවා. And therefore m is 0.4. So 40 or 1000 or 20. Now this is water into theta. Theta. And I put the 0 minus theta is theta. Is that clear? If you got that term, please raise the hand. I need responses from everyone. Everyone, Ban? Maybe when they do now, who is the one who gives heat? How the method heat take the කවුද මෙතන heat එක දෙන්නේ? heat එක දෙන්නේ calorimetry plus water. calorimetry plus water heat එක දීලා මොකද කරන්නේ? Celsius 20 ඉඳන් Celsius theta දක්වාගේ temperature අඩු කරනවා. එහෙනම් මෙන්න මේක තමයි calorimetry water එක දීපු heat එක. calorimetry water එකයි දීපු heat එක තමයි මේක. ඒක තේරුණා නේද උස්සන්න? calorimetry water දීපු heat එක මේකයි කියලා තේරුම් ගන්නත් උස. I need responses from everyone. මම හැමෝගෙම ඩටක් ගන්න respond එක දෙන්න පුළුවන් නම් හොඳයි. හරි, thank you. Thank you. ඊළඟට ඒ calorimetry මොකද්ද water දීපු heat එකෙන් මොකද උනේ? මොකද උනේ පුතේ? අර ice එක මොකද උනේ? ice එක දිය වුණා මුලින්. නේද? 0 Celsius ice will be converted into 0 Celsius water. 0 Celsius water. Then that heat is equal to ml. That heat is equal to ml. We have calculated that thing. ml is 13,440. Is that clear? Hey, 13,000. Okay. I need responses from everyone. I'm going to give a responding on. Alright. දැන් පුතේ අයිස් ටික ඔය අයිස් ටික එතන තියලා නිකන් ඉන්නේ නෑනේ. ඔය අයිස් ටික දිනුනාට පස්සේ මොකද වෙන්නේ? ටෙම්පරේචර් එක එන්නේ වැඩි වෙනවා යන්නේ. නේද? අයිස් ටික වෝටර් බාරපත් වුණාට පස්සේ ඒ වෝටර් වල තියෙන ටෙම්පරේචර් එන්නේ වැඩි වෙලා අර ෆයිනල් ටෙම්පරේචර් එකටපත් වෙනවා. හරිද? දැන් වෝටර් වල එක කෑල්ලක් අලු ටෙම්පරේචර් එක අනිත් කෑල්ල වැඩි ටෙම්පරේචර් එක දෙන්නේ නැහැනේ. ටික කාලයක් යද්දී ඒක එකම ටෙම්පරේචර් බවටපත් වෙනවා. හරිද? ඒක තමයි ෆයිනල් ටෙම්පරේචර්. ඒක තමයි අපිට හොයන්න තියෙන්නේ. හරි. එහෙනම් මෙතනින් මේ ගත්ත හීට් එකේ මොකද කරන්න ඕනි? මෙයාව කන්වර්ට් කරන්න ඕනි ලික්විඩ් ෆෝම් එකට. ලික්විඩ් ෆෝම් එකට කන්වර්ට් කරලා ඒ ලික්විඩ් ටික අරගෙන යන්න ඕනි ෆයිනල් ටෙම්පරේචර් දක්වා. හරිද? මොකද්ද කරන කාර්යය? මොකද්ද කරන වර්ක් ඩන් එක? මොකද්ද කරන වර්ක් ඩන් එක? 0 Celsius ice should be converted into 0 Celsius water. Then that water amount should be converted into final temperature. Water with final temperature. Is that clear? එහෙනම් මේ water ටික ගෙනියන්න ඕනි final temperature. හරි. ඒක තේරෙනවද පුතා? I need response from everyone. හැමෝම respond එකක් දෙන්න. තේරුණාද කියන්නේ? හරිද ගාන්ධි? Look at this somebody. තේරෙනවද? දැන් පුතේ මෙයා කන්වර්ට් මෙයා දැන් වතුර වෙලා ඉන්නේ. දැන් වතුර වෙලා ඉන්නේ. දැන් අයිස් ටිකක් මෙන්න අයිස් ටික. මේ අයිස් ටික වෝටර් බවට කන්වර්ට් වුණාට පස්සේ මෙයාගේ තියෙන පාටිකල්ස් වෙනස් වෙනවද? එයාගේ තියෙන පාටිකල් amount එක වෙනස් වෙනවද? නැහැ. පාටිකල් amount එක වෙනස් වෙන්නේ නැහැ. ඒක නිසා කවදාකවත් අයිස් ටිකක් වෝටර් වුණා කියලා ඒකේ mass එක වෙනස් වෙන්නේ නැහැ. Mass is a constant. Mass is a constant. Therefore, when converting ice into water or water into ice, definitely mass is a constant. Density and volume can be changed. But mass is a constant because the amount of particles are constant. Particle amount එක එකයි පුතේ. ආයෙ වෙනස් වෙන්නේ නැහැ. ඒක නිසා දැන් මොකද වෙන්නේ? මේ ice ටික water වුණා. මේ water ටික මේ 0 Celsius water ටික දැන් ගෙනියන්න ඕනි theta Celsius water. මොකක්ද වෙන්න ඕනේ එතන? මම අදින්න පස්ස. Ice at 0 Celsius, it should be converted into water at 0 Celsius. This involves ml. Then this water should be converted into water at theta Celsius. Final temperature. This process the heat related to this process is equal to ml. Heat related to this process should be equal to mc theta, because the phase is equal. ඒක තේරෙනවද තුස්සා? පැහැදිලි නේද තුස්සා? දැන් තේරෙනවද තුස්සා? මම මේ මොකක්ද කරේ කියලා දැන් තේරෙනවද තුස්සා? I need responses from everyone. හරිද? Okay. Viret? තේරෙනවද? Okay. That's all. Then 740 into 280 minus theta is equal 13,440 plus this one will be cancelled out. Preparing apply, that's it. Follow. The page. ඔබට තියෙන්නේ බලන්න මේක මේ කඩු කරන්න. එයි අපේ මතකයි ගියා. ඒක පස්සේ නෑ. උලේට තුන 8යි. තුන 12යි සුලට. Therefore 9.8 is equal 1360. Amen. Theta can be the one. මෙයාව දෙකෙන් බෙදුවොත් පුතේ 450යි 454ක් වෙනවා. 454ක් මෙයාට එකතු කරොත් ඔහෙන් දෙකක් පිටුයි 6යි. Okay. And theta should be equal 1.566. 1.566. බලන්න කොහොමද නැත්te කියලා? මේක මම බැලුවා දෙකපාරම එක නිකන් 400 ගණනක් එකතු වෙලා වගේ තියෙන්නේ. මම ඒ නිසා මේක දෙකෙන් බෙදුවා. දෙකෙන් බෙදුවාම එන්නේ 454යි. 454ක් එකතු කරන් 1302යි එන්නේ. 1302යි කියන්නේ 454 කියන්නේ 0.5 නේ. 0.5 එහෙනම් මේක අනිවාර්යයෙන් 1.5 වෙනවා. ආසන්නශය 1.5 වෙනවා. ඒක තේරෙනවද තුස්සා? පැහැදිලි නේද තුස්සා? I need responses from everyone. තේරෙනවද තුස්සානේ? Very good. දැන් ඔයගොල්ලෝ homework එකක් විදිහට heat calorimetry tube එකේ පළවෙනි question 26. පළවෙනි question 26 ඉවර වෙන්න ඕනේ. ඒක ඉවර වෙලා මට answer sheets එවන්න. මට answer sheets එවන්න බලන්න. මොකද මේ heat lesson එක සෙල්ලම් කරන්න එපා. heat lesson එක පුතේ හරියට අර theory part එක ලේසි තේරුම් ගන්න. හැබැයි ඒක apply කරන්න ගියහම අර questions තියෙනවා ළමයි උතර. හරි. ඒකයි මම කියන්නේ හරියට තේරුම් ගන්න ඕනේ තරක් මේක තේරුම් අරගෙන questions කරලා තේරුම් ගන්න මොකද්ද මේ වෙන්නේ කියන දේ. හරි. ඒ නිසා සෙල්ලමකට ගන්න එපා, නොකර ඉන්න එපා. next week වෙන කලින් අනිවාර්යෙන් මට heat lesson එකේ tute එකේ පුතේ පළවෙනි questions 26 හදලා එවන්න. තේරියද? තේරෙනවද? දැන් ඉදිරිය භාගයට. Okay. Hi. Then we can have a really good one. Okay, have finished? Have finished idea? Okay. Then we can complete today's lesson today. Then we can complete today's lesson. There's only one part to be discussed to complete calorimetry. Calorimetry කතා කරලා එක part එකදී so then we can go for the past paper questions as well as the questioning tube. Therefore, please do the question tube. Please do the tube පුතේ නැත්තම් වෙලා නැහැ. නැත්තම් වෙලා නැහැ ඉතුරු කරගන්න එපා. බැලන්ස් කරගන්න එපා. දැන් ඔයගොල්ලෝ උන්ටන් බැලන්ස් කරලා තියෙනවා මැට්‍රික්ස් වල. හරි. මේ ටියුට් නම් මම දන්න තරමින් කරලා නැහැ මට. ඒවල තියෙන බොහොම අඩු ප්‍රමාණයක්. ඒ නිසා මෙතනින් ඉස්සරහට ආයෙත් ටියුට් බැලන්ස් තියාගන්න එපා කරන්න. ඉවර කරලා දාන්න ටියුට් ඉවර කරලා දාන්න. හරි. එහෙනම් පළවෙනි question share කරලා මට එවන්න පුතේ. That is the homework. Okay. Then we can complete today's lesson. Everyone, good night. I'm පුතේ.
Thank you, sir. Good night, sir.
Yeah, good night.